It's me. Hey, here's the problem. By me. Anyway, I was gonna make a Taylor Swift joke, but maybe I'm not your anti-hero. Anyway, so let's take a look. Um, what does this say? So this is a quadrilateral proof, and in quadrilateral A, B, C, D, E and F are points, and B, C, and AD respectively are line segments. And BG, D, and EG, F are line segments drawn such that angle ABG is congruent to angle CDG, and line segment AB is congruent to CD, and CE is congruent to AF. Prove FG is congruent to EG. Okay, so with these quadrilateral proofs, odds are you're gonna have to prove it's a parallelogram because you kind of need those facts to help prove other things. And you probably need to prove some triangles congruent. So I'm gonna think about proving these triangles congruent. Why? Because, well, these line segments are in those triangles. So that's what I'm gonna try and do. So let's just go ahead and get started. Here we go. Let's start with the given information. So this angle here, ABG, is congruent to angle CDG. AB is congruent to CD, and it's helpful to mark up your diagram. Don't mark it with everything, just mark it with the things that you know. And then CE is congruent to AF. All right, so what are our statements and reasons? So the first statement is always going to be the given information. So if you're in doubt, just copy all of this information down. I'm just going to start with the stuff that I know I need in my proof, but I've done this a few times, so kind of know what to do. So I'm just going to list out the given information I need. So that's this stuff here. So ABG is congruent to CDG, those angles. These line segments, AB and CD are congruent to each other, and CE is congruent to AF. Why? The reason is given. All right, next step. I'm going to use some facts that I've been given here to prove this thing's a parallelogram. So first off, let's think about these angles, right? We have that little Z shape. Ooh, that means that those lines need to be parallel if those are congruent alternate interior angles. So that's what I've stated. Line segment AB is parallel to line segment CD. Why? Because congruent alternate interior angles form parallel lines. Yes, you can mark that on the diagram if you wanted with like two little arrows. I didn't do that. Now I know that this quadrilateral is a parallelogram. Why? It has one set of sides that are congruent and parallel. So AB is congruent to CD. That was given. And I've just proven they're parallel. So I'm going to actually say quadrilateral ABCD is a parallelogram. Now I can use that fact to prove that these sides, AD and BC, are congruent and parallel. AD is congruent to BC, and AD is parallel to BC. Why? Opposite sides of a parallelogram are congruent and parallel. So you could split that out as two statements if you wanted. I just made it into one. It's a little easier. Now I can use those facts to help me prove some things about the triangles. Notice here, I've already marked these angles congruent. If you ever see like that X shape, think about vertical angles. So angle BGE is congruent to angle DGF. Why? Vertical angles are congruent. Now I have one set of angles, right? We need three things to prove triangles are congruent. I have one set of angles. I need two more things. So that's the first one. By the way, if this were like a 6-point proof, which I think it was, you can actually like accumulate points pretty easily just by starting to write down things that you know. Like if I just wrote down this and the given information and nothing else, I'd get a point. So think of it as a way to just like accumulate points. There's 1 out of 6. So let's keep going. All right. Notice I have these lines are parallel, right? Well, I can actually go ahead and prove some angles are congruent. I could prove like this angle here is congruent to this one, or I could prove this angle is congruent to this one. I'm going to go with those angles, right? Let's say angle BEG is congruent to angle DFG. Why? Alternate interior angles are congruent. I could have listed these as well, GBE and FDG. Those are also congruent alternate interior angles, but I'm going to kind of go with this like little Z shape here. And now I have another set of angles. Now I have two sets of angles. I need a side though. So, all right. Well, notice here, I proved that AD is congruent to BC. So this line segment is congruent to this one. And they gave us that EC is congruent to AF. So by subtraction, I know that DF is congruent to BE. So I'm just going to call that subtraction postulate. Just imagine, like if this length of this line segment is say 10, and AD would have to be 10 because they're the same. And then if I subtract some number, like call it 3, I don't know, then these would both have to be 7. So there you go, subtraction postulate. You could just say subtraction. You don't have to say postulate. But anyway, now look, the triangles are congruent. Why? Oh, angle, angle, side. Now don't get confused between angle, side, angle, because the side isn't sandwiched between the two angles, right? So BE is congruent to FD, which is what I proved right here, or DF. And it's angle, angle, side. It's not the included side. So that's actually what I'm trying to prove. So now FG is congruent to EG. Why? Corresponding parts of congruent triangles are congruent. Sorry, that got kind of like overlaid by the Doceri watermark there. But it says corresponding parts of congruent triangles are congruent, or you could just say CPCTC. There you go. There's a quadrilateral proof, and I have no idea how long that took, but hopefully that helps. And thanks for watching. I'll see you in class. Bye.